Unit 1B, Lesson 1. This lesson will align with 6.3 in your textbooks. The one standard we are going to discuss in this lesson: understand that polynomials form a system analogous to the integers, namely, they are closed under the operations of addition, subtraction, and multiplication. So we're going to add, subtract, and multiply polynomials. Before we get started into examples, I'm sure some of you are wondering what that standard exactly means. So what does the standard mean by polynomials form a system analogous to the integers? What that means is if I take two integers, let's just say 6 plus 8, and I add them together, my result is going to be 14. If I add any two integers together, the result is going to be an integer. Same thing if I would subtract two integers. My result is still going to be an integer. And if I multiply, again, the result will be an integer. That's what it means by polynomials form a system analogous to the integers. They're closed under the operations of addition, subtraction, and multiplication. So just like we went through these examples with integers, if I add any two polynomials together, the result is going to be a polynomial. If I subtract or multiply two or more polynomials together, the result will still be a polynomial. So that's what this standard is getting to. That's what we need to understand. Question before we move on: why does this not include division? Well, suppose we take these same two integers, 6 and 8, and I take 6 divided by 8. We know that will simplify down to 3/4. This is not an integer. So division is not closed for integers. If I take two integers and divide them, my result will not always be an integer. It might be a rational number. Next, we're going to add or subtract a few polynomials. The first example, we have 3x squared minus 7. And we're going to add to that 4x squared minus 2x plus 8. When we add polynomials, we combine like terms. So we're going to add or subtract the coefficients of like terms. Like terms are terms that have a variable raised to the same power. So in this problem, we have an x squared and an x squared. These two terms are like terms. We're going to combine those together. So I'm taking 3x squared plus 4x squared to get 7x squared. I want to go in descending order. I want to find, is there any x terms? In my first polynomial, there's no x terms, but in my second one, there is. So now we have minus 2x. Now we go back to our constants. Negative 7 plus 8 is a positive 1. So we're looking for any variable raised to a power, any of those like terms, combine the coefficients, and now this is our result. We started with two polynomials. Our result is a polynomial as well. Okay? Polynomials are closed under addition. Next problem, now we're going to subtract two polynomials. We have 12x cubed minus 2x plus 3, and we're subtracting from that 4x minus 8 plus 3x cubed. A couple of things we can do to start this problem. First, if it's easier for you to write these polynomials in standard form, we can do that. The first one is already in standard form. The second one is not. So if you wanted to rewrite this to make it easier to line up your like terms, go ahead and do that. It is not necessary though. And if we have a subtraction problem, it's easier to turn this into an addition problem. And we do that by simply changing this to an addition problem. And now we have to change the sign on every term on the polynomial that follows. We do nothing with the polynomial we start with. We're only going to change the signs on the polynomial that follows, the terms. So this will become a negative 4x plus 8, and now we're going to add a negative 3x cubed. Now we can go through combine like terms. Our highest degree is 3, so we have 12x cubed plus a negative 3x cubed, so 12 minus 3, that is going to get us 9x cubed. Next highest term is an x to the first. We have a negative 2x plus a negative 4x, which is a negative 6x, so we minus 6x. And now we have our constants. 3 plus 8 gives us 11. So we were subtracting two polynomials. Our result is still a polynomial. Polynomials are closed under the operation of subtraction. Before we move on to multiplication, there's a mistake some of you are going to make. For instance, when I combine 12x cubed and negative 3x cubed, notice we do nothing with the exponents on these terms, on our variable. If I have an x cubed and an x cubed, if I'm adding or subtracting those like terms, all we do is combine the coefficients. We do not combine the exponents. So I'm not going to take, if I have x cubed plus x cubed, that does not give us x to the sixth. All right? So for addition and subtraction, all you do for like terms is combine the coefficients. Now we are going to go through a few problems where we multiply polynomials together. The first one, we have the polynomial 8y, and we're going to multiply that by the polynomial 2y squared minus 7. In this example, all we have to do is use the distributive property. I'm going to take 8y times 2y squared, and then I'm going to multiply 8y by negative 7. When we multiply polynomials, we are multiplying the coefficients together. So I'm taking 8 times 2 to get 16. And now, since we're multiplying on our variable, I have to take y times y squared. So y to the first times y squared. If we're multiplying with the same base, we add the exponents. So this will become y cubed. Now I'm taking 8y times negative 7. So 8 times negative 7 gives us negative 56. And that's just going to be y. We're multiplying two polynomials. If we multiply two polynomials, the result will still be a polynomial. Last example, we have a binomial multiplied by a trinomial, 3x squared minus 11 times 4x squared plus 5x minus 1. In this, we have to use a form of the FOIL method. We're going to take 3x squared times all three terms in our second polynomial, and then we're going to take negative 11 times all three terms in our second polynomial. After that, we have to combine like terms. So 3x squared times 4x squared is going to be 12x to the fourth. 3x squared times 5x is going to be 15x cubed. And then 3x squared times negative 1 is just minus 3x squared. Now we have to go through and use negative 11 and multiply by all three terms. Negative 11 times 4x squared is negative 44x squared. Negative 11 times 5x is minus 55x. And then negative 11 times negative 1 is positive 11. Final step, we need to go through, combine any like terms. We only have one x to the fourth term, so we have 12x to the fourth. There's only one x cubed term, plus 15x cubed. We have two terms that are x squared, negative 3 minus 44 minus 47x squared. And at the end, minus 55x plus 11. We started with two polynomials, multiplied them together. Our result is still a polynomial. Polynomials are closed under the operation of multiplication. In this lesson, we added, subtracted, and multiplied polynomials together. The main thing you need to take away from this lesson is that if we add, subtract, or multiply two or more polynomials, the result is still going to be a polynomial. All right, polynomials form a system analogous to the integers. Remember, this does not hold true for division.